using a table of values. So just as a refresher, remember that our table of values is what I just drew an arrow to. And when we're thinking linear rule, we need to be thinking what's our general form, which is y equals mx plus c. So remember the elements of this will be that c is our y-intercept and m is our gradient. In addition to this, we can also see that our y and x value can be found on through our table of values. So for example, for this particular linear rule, if x is equal to -2, then y will be equal to -1. Just like if x is equal to 1, y will equal 5. So let's look at this particular table of values. What we can notice straight away is that there's an x equals 0 value. So just here, where we've got x is equal to 0, what we can see is that y is equal to 3 at this particular point. So if I were to write that out, or label it as my y-intercept, I can also write my coordinate as 0, 3. Just like if I were to write a coordinate for that point there, I'd be writing 2, 7. Let's pick another one. We've got here, we can write -2 and -1. So you can see that there's a relationship between each of the x values and their corresponding y value. Our job is to find what rule connects this relationship. So if we go back to the general equation, we can see that the rule says that y is equal to mx plus c, and c being our y-intercept. What we've been fortunate enough with this particular table of values is to actually be given our y-intercept. So you can see here that our y-intercept is 3. So that c is equal to 3. So first step, I'm going to rewrite the equation with the y-intercept, which remember is c. So I'm going to write y is equal to mx plus 3. So now my second step is going to be to solve for the gradient. So I'm going to find the gradient. And just like before, I'm going to use the equation y2 minus y1 ln x2 minus x1. So I'm going to pick two coordinates, and you do need two coordinates to do this. And you can pick any two coordinates that you have been given in this table of values. So I'm going to say, select -2 and -1 and 1, 5. So substituting these now into my equation, I'm going to have 5 minus -1 all on 1 minus -2. Now be very careful when dealing with your negatives, so that becomes a positive, and this down here becomes a positive. So that is equal to 6 on 3, and therefore giving us m equals 2. So what this is telling us is, and remember 2 is positive, right? So that means our gradient is positive. So what we should see is a positive relationship between our x and y value. When I say positive, if we go back to our table of values, I'll just pick a different color. What we should see is that as x increases, notice that y is also increasing. So this means that there is a positive relationship because of the gradient. So remember I said the gradient is positive, and we can see that as m equals 2, which means that as x increases, y should as well. So now that we've got m equals 2, I'm going to rewrite the equation. Having found m, or having found the gradient. So therefore, my equation will be y equals 2x plus 3. So now a way we can check that this equation is correct is if we substitute any x value we've been given, say for example I'm just going to write here, this is check. Let's say x is equal 2. So if I substitute 2 into the equation we've just found, I should get y is equal to 7. So let's check that that's correct. So I've got y equals 2 times 2 plus 3, which will give me, through order of operations, 4 plus 3, y is equal to 7. So what this has told me is that this particular relationship says that when x is equal to 2, y is equal to 7. That's correct, and we can see that if we look back at our table of values, when x is 2, y is 7. And what we've just proven is that our equation we found, so y equals 2x plus 3, is correct for the given values in our table of values. So let's move on to a bit more of a complicated question, again using the table of values. So here, what we can see is that we haven't actually been given any intercept that we can notice. What we do see is that x is increasing, but notice that as x is increasing, y is actually decreasing, right? Because remember, negative 26 is much smaller than negative 20. So y is decreasing. What we should be expecting is that this relationship suggests that there is a negative relationship, because notice that x is increasing but y is decreasing. So could that mean that our gradient is negative? Well, we can work that out and check whether our hypothesis is correct. So again, linear rule, we should be thinking y equals mx plus c. So let's find our gradient first and prove whether or not our gradient is positive or negative. So given that we need to find our gradient, we need to have two coordinates. Let's pick 4, negative 18, and let's pick 8 and negative 26. So using the y2 minus y1 on x2 minus x1 method, I've got m is equal to negative 26 minus negative 18, all on 8 minus 4. So m is equal to negative 26 plus 18 on 4. Again, take very good care when dealing with your negatives. If you're not sure, by all means consult your calculator. So negative 26 plus 18 will give me negative 8 on 4, which means that m is equal to negative 2. Notice here that our gradient is negative. And what we've just managed to do is prove our hypothesis correct in the way that we said I said at the very start that as x is increasing, y is decreasing. And I floated the idea that potentially just by looking at our table of values, we could identify that the gradient is negative. Mathematically, we've just proven that the gradient is negative too. So that's a pretty neat little trick. So my second step would be to rewrite the equation, given that we've just found m. So I'm going to have y equals negative 2x plus c. So now to solve for the y-intercept, or solve for c, I'm going to have to substitute a coordinate in. Now I can pick any coordinate from the table of values that we've been given. So let's pick the coordinate 6, negative 22. So I would highly advise that if you're going to do this example as part of your practice, pick another set of coordinates. Check and see whether or not you get the same linear rule that I did. So now substituting the coordinate into what we found in part 2, we can see that we've got y being negative 22, so let's substitute that in, equals negative 2 times 6 plus c. Just write that. So now I've got negative 22 equals negative 12 plus c. Solving for c means that I need to take this negative 12 to the other side. So that becomes negative 22 plus 12 equals c, which will give me negative 10 equals c, and c therefore is equal to negative 10. So now I'm going to rewrite the equation for the last time with my new values. So now that I've found c, I can rewrite it as y is equal to negative 2x minus 10. And that is the linear rule that connects these particular points together. So remember that this is proving to us that there is a relationship between each of the x values given and the y values given. What we have just done is found a rule to connect this relationship.